Already in this video, I'm going to show you what a dilution series is. I'm going to be using one of these well plates. I'm going to put a drop, I guess I can do that right now, of food coloring right here in that well right there. And so these wells sort of like test tubes, except, shallow. So there's that. Just one drop there. And imagine that one drop is right here. And there's like 10 particles. We use 10 because it's an easy number. And so there's 10 particles right there that make up that food coloring. And what I want to do is dilute it 10 times. So I want each of those particles to get 10 times further apart. That would be a 1/10 concentration compared to this. To do that, we're going to add some water. Now, food coloring is water-based, so it's just like adding more water to it. We're going to talk in terms of drops, not milliliters, not gallons, not ounces, not tons. Now, here I have some water to add to it, and I'll do that in just a second. But before I add this water to that drop, let's talk about it right here. If I go times 10, that means that you're spreading 10 times further apart. And let's, imagine putting those 10 dots over here and then adding water. How much water would you add? The tendency for a lot of people is to say, add 10 drops of water, speaking in terms of drops here. But watch this. 1, 2, I'm taking these 10 dots here, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. We had all of them confined to one drop. Now they're no longer restricted to that. They can swim around in the volume of 10 drops. Okay, so that would be a times 10 dilution, times 10 dilution, or a 1/10 concentration. So this would be times 1. And now, what if I wanted to go times 100? Well, I could now add, I'd have to get a bigger well plate, add 99 drops, right? No, there's another way. We're going to take that one drop, put it down here, there it is, and then add 9 drops of water. I suppose I could draw them in blue, couldn't I? Well, no, just leave it in red. So there's, that 9 drops. So that would bring it to times 100. Could say times 10 to the 2, 10 to the 1, 10 to the 0. Is another way to do it, just because we may run out of room and we'll want to do that. 10 to the 1, and then this is times 10 to the 2. Okay? All right. So now let's put this out of the way. Let's grab some water here. These are micropipettes. Okay? These we can use counting drops here. So here we go. I'm going to start counting the drops. I'm going to get my glasses on first. Multiply what I see here by 3.25. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm almost thinking to go to 10 myself. So there's 9 right there. Okay? Next thing we're going to want to do, take another micropipette, mix that up good. All well mixed up. And then we'll take one of those. A little bit of adhesion here up to the side there. So we understand there'll be a little bit of a mistake right there, but not much I can do about it. So now I'm going to take one of those drops right there. And this would have to be cleaned out now. So we have, these two have the same concentration. There's more of this one, but they have the same concentration. Okay. Now what am I going to do? And I can label that. I'll just put a 2 right there. The times 1 I've already messed up, because we had the times 1 was the original drop. Okay, so we're good with that. Now let's go 10 to the 3. That's a 10. Hold on. That's 10 to the, what is that? That's times 10. Whoops. That's times 10. This is going to be times 10 raised to the second power, I think. Hold on. I got that right? Yes. Okay. Ahead of myself here. So we have to take some more water, 9 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 drops there. Clean water, put that back. Have to take another pipette, get this all mixed up. And take one of those drops and put right there. There it is. Now put this in here, it has to be cleaned out. Now we need 9 drops of water, because we're making it times 1,000. So this is what you call a dilution series. 1, 2, 3, 4, 5, 6, 7, 8, 9. Clean water, and put that back. So there's 10 to the 3 power, 1,000. Diluted so that the particles are 1,000 times further apart. We have to take another pipette here. Make sure that's all well mixed up. Okay. And we take one of those drops and put it right there. That has to be cleaned out. Now this will be times 10 to the 4, 10 thousandths. And another pipe. Let's see, where am I at? Okay, I gotta get water now. More water. One, 2, 3, 4, 5, 6, 7, 8, 9. There's that. Now, another pipette. So this is called a dilution series. We'll take one of those now. It's all stirred up and everything. 1 drop for a 10 to the 5th. Let's put a 5 there so we don't get confused. Don't forget. I've already put water in it, and here we go. And there's a little bubble in there. I don't like that. I'm going to go 9 drops now, right into this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 drops there. Now, I get another pipette. That all mixed up. Make sure it's well mixed. And I don't even know if I see any food coloring in that anymore, but I'll take one now, one of those drops. We know there is some. Okay. Now that would be 1/1,000,000 of a concentration, or times 1,000,000. But we haven't got it times 1,000,000 yet until we put the water in. So here we go with the water, 9 drops. Nine. There we go. So now we've made all the solutions along the top, and we have all this contaminated water here. It's wastewater. Okay, and I'm going to want to wonder, what is the concentration of that wastewater? And looking at it right there, well, it's pretty deep. it looks pretty blue. Okay, kind of looks like it's times 10 to the 1000 dilution. But here's what we have to do. We have to compare it to these. So I'm going to take a bunch of it, and I'm going to take 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 drops right there. 10 drops right here. 5, 6, 7, 8, 9, 10. You got to take the same amount as these things we're comparing it to. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I should have all that, and I'm going to kind of stir it up, get it so all of these are kind of on the bottom there somehow. A little bit of adhesion, cohesion, lots of cohesion there. Is that the right word? I think I got it. But anyway, yeah, I don't, it's really hard. I think it's a little darker. I think this is obviously darker. Where do I point with this? This right here, little darker than that. This one, that's a tough one. It almost looks like that one. Here, I think I see a little tinge of blue here compared to that. Similarly right there. I'm going to go with the 4. I'm going to go with the 4. Now, it's not going to be perfect because, between each of these, there would be even, fractions of dilutions between there. I'm going to go with this one. This looks like, now, before, look when I showed you this, but it's so deep. Here, these are all the same depth. So we're looking through the same thickness. This is so thick that's why it looks more blue. But, that would make me think 1,000, but here I think it's 10,000. I think I don't even really, if I just look at that and then I think, wow, they all look the same. So, but there is some still food coloring in this one and this one. Now, that means that the wastewater, which is our unknown. This is like our unknown. Unknown. So should we throw it in the ocean? It looks like it's a times 10 to the 4, or a 1 over 10,000 concentration. That dilution or this concentration? So the concentration of the wastewater, 1 over 10,000. I think that is probably as far as I can go. I could go into another subject on this, but we're nearing 15 minutes here, so I'm going to have to stop this. I got 13, 14. Yeah, about 14. Yeah.